welcome to an introduction to one of our recent research and innovation projects in Vard Group. I'm going to give you a run through about the details on the Ocean Charger project, which is centering around enabling offshore charging of battery powered vessels offshore. First, a little bit about the background of the project. It's sort of the concept of charging offshore spun off from a project called the PITSO project, which we started in 2021. It's very recently actually completed, and that project was looking into how we could enable fully electric PSV operations from shore to the oil fields. And that project showed we did an in-depth analysis on vessel operations together with, among others, Solstad offshore and Equinor, and we found that this is fully possible today if we could make charging available offshore. So that's the critical factor. And thinking a bit further, we realized that the SOV is actually more suitable for this concept, since it's operating inside a wind farm and usually only at daytime, so it can charge during the night, and we don't have to, and it will not compromise the operation. So as long as we can equip it with a battery package and we can enable it in a safe way to connect and deconnect, this is fully possible with today's technology. So this evolved into a project application together with a large consortium of partners. I will come back to that. And we were awarded 38 million NOK of funding just before Christmas. So it was a nice Christmas present for all of us. So the project started off in February this year, and it will run until May 2026, roughly 3 years. So this is the project partners. It's 18 in all, 10 commercial companies. We have we have 3 different subsidiaries of Vard Group with us. We have Corvus on the battery side. We have 2 ship owners, Solstad Offshore and RAM. We'll come back to that. We have 2 energy companies or development companies. Equinor, most of you know. Source Galileo is another one we have with us. We have Plug. Some of you know about them. They are responsible for the shore side in the project. We have Shoreline that is developing logistics solutions for wind farms. We have 4 research institutions, 2 SINTEF departments, NORS and University of Bergen. We have 2 catapult centers. We are doing full-scale pilot testing in the project. I will come back to that. And 2 clusters, Maritime Cleantech and Norwegian Offshore Wind. And a few words on the Green Platform funding call. This is a combined effort by the Research Council of Norway, Innovation Norway and SIVA. So, as I briefly mentioned, we have 2 catapult centers, and the reason we have them in there is because one of the goals of the project is to demonstrate, first to simulate it in a digital environment to verify that our solution is actually functioning, and then we will install it on a real SOV and full-scale test it against a floating windmill in March 2024. This is the Zephyrus wind turbine. It's operated by Sustainable Energy Catapult. So it's the previous high wind demo windmill, if anybody has heard about that. It's now taken over by Sustainable Energy Catapult and renamed Zephyrus. So this is a floating windmill, so it has a motion on its own. So that complicates further the prospect of connecting and deconnecting. So, what are we going to do? This beautiful ship is modern state-of-the-art SOV, just delivered from a Vard shipyard, the Rem Power. It's a Rem offshore vessel. This is the one that we will use for the full-scale testing. So the 6 different work packages in the project you can see around the ship. Number 1 is the development, simulation and full-scale testing package. And that will run for about 1.5 years, and the experiences that we gain from this will then be fed back into the other work packages. Number 2, smart maritime operations in offshore wind. It's headed by University of Bergen, and they will look into the logistics of SOV operations on wind farms, and particularly how the charging option will change, or potentially can change, the operations. Number 3, energy systems and energy carriers. This is run by SINTEF Ocean, and what they will do is that they will take this solution and see how this can be applied in a wider perspective on the Norwegian coast for short sea shipping. Number 4, automation. We are charging with, or we are going to charge with 11 kilovolts and above 6 megawatts. So it's a lot of power, and it's not exactly your 12 volt or your 230 in your sockets at home. So it's dangerous stuff. So from a health perspective and also from a reliability perspective, we have to look into how we can automate the connection and the decoupling operations as much as possible. Number 5, alternative energy transfer solutions. A bit cryptical title, but what it is actually is the test we are going to do is with a standardized IP67 plug connection. Work package number 5 will look into different options of energy transfer, electrical energy transfer. So among other things, they will look into wireless charging. SINTEF Energy has been looking into this in the past, and now they will look into this in a bigger perspective. There are a number of advantages by going wireless, which are maybe apparent, but of course it has its limitations as well. So this is what we're going to reveal. And last but not the least, standardization is a work package headed by Maritime Cleantech, and they will not. We don't have a target to standardize this. That's a big job in itself. But we will prepare the ground for it. So we will maybe we will suggest the standard. One of the key factors is that we need to have a system that can be used both in port and offshore. So the vessels have one common system for both applications. That was it. So thank you for watching and listening. And if you have any questions, please come into the stand and approach me or any of my colleagues. Grab a coffee or a Coke or a carrot. Thank you.